Welcome to the Rig Doctor podcast, where I'm giving out remedies to soothe your ailing tone and fix your sick pedal boards. I'm your host, Mason Marangella, aka the Rig Doctor. I've been building rigs for over a decade for many of the industry's top pros, and now I'm giving away all my secrets to DIYers just like you. I'm giving away all my tricks, tips, resources, and easy hacks that I've learned over the years so that you too can build a rig just like the pros. If you want to support this podcast, you can do so by sharing it on social media, subscribing to our podcast, or following us on Instagram, Facebook, and YouTube. You can also support this podcast financially by purchasing one of my products, Vertex Effects, from any of our authorized dealers, or becoming a member of our Patreon page. We have several membership levels as low as $4.99 a month that give you exclusive access to private live streams and Q&As, exclusive deals and discounts on Vertex products, as well as access to new product releases before anybody else. Also, you can get personalized one-on-one phone and email consultations with me, the Rig Doctor. This could be as in-depth as troubleshooting your pedalboard with me in real time, or advising you on the best way to build your next rig. As always, I don't want money to be the block that prevents you from having your best possible tone. If you cannot afford to be a supporting member of our Patreon, you can always email us at info@vertexeffects.com, and our team will grant you full access to our standard tier of privileges on Patreon, free of charge, no means testing required. We trust that when your financial circumstances change, you will let us know and become a supporting member at that time. I'd like to thank our sponsors, Blue Microphones, for providing Yeti microphones for us to record all of our podcasts with, as well as our live streams. I'd also like to thank my own company, Vertex Effects, for providing the resources to make all of this stuff happen. If you are interested in sponsoring this podcast, you can always email us at info@vertexeffects.com, and we would be happy to hear from you. In this episode, I'm speaking with Poul of Cioks Power Supplies. One thing that he corrected me on early on is I think a lot of people assume that his name is Cioks because the power supply, plural, indicates the S at the end, but it is actually, in fact, Poul Ciok. So Poul spoke to me today about power supplies, and he makes one of my favorite power supplies that's out there, which is the Cioks DC7, DC4. Their current version of switch mode power supplies are really unparalleled, not only in terms of their size, but in terms of their capacity to vary in voltage between 9 and 18 volts. And every single one of their outputs at 9 volts provides 660 milliamps. So it's pretty incredible at how small it is at 1 inch profile high that it's able to provide so many options in terms of power, and also a digital readout that shows you how close to max you are of the total available current in the supply, which no other supply does. Poul and I talked today all things power supplies, the differences between switch mode power supplies versus linear power supplies, and really gives, I think, the most in-depth tutorial that I've ever heard from an expert on power supplies about the key differences in why you may want to choose a switch mode power supply versus a linear supply. And we've talked about this a bit on the YouTube side, but I think he really gets into the theoretical aspect, and I tried to keep it in a realm where it's still understandable for the majority of listeners. So I think that people can kind of understand how this might translate to their own rigs and where they may want to be careful when choosing a power supply in the future, or how they may want to alter some of their wire dressing, or where they have pedals and devices on their current pedal boards if they are in fact using a linear supply, which has a toroidal or a C-core style transformer. So this is going to be a little bit more technical than usual, but I think that I kept the structure of the questions so that we would stay out of the weeds on anything that got too overwhelming. And I think Poul just gives so many good examples of what is workable in a power supply, what they go for, their process, and why they are making some of the best power supplies out there. We also talk about some of the other brands as well, and talk about kind of pros and cons of those, even some which are switch mode power supplies like his DC7 and some of the other models are. So this is a really fun one. So without any more delay, let's get into it. Paul Cioks of Cioks Power Supplies. Yeah, well, wonderful. Well, I really appreciate, Paul, having you. Certainly, in my mind, you have the most sophisticated power supplies out there, and it's something that I even use on my own pedal boards. And those that are not including your power supplies, I'm already in the process of converting them to your new DC7, DC4 power supplies, and I see that you have the DC10 is also a switch mode one, correct?
No. There
not.
are two DC10s actually. The first one that came out in 2010, it's purely linear, and the DC10 Link has got one channel which is based on switch mode technology, but it's actually getting its source from a toroidal transformer. So the first part is linear. And then the conversion into the outlet is made in the switch mode domain.
Got it. So the largest of your switch mode supplies is the DC7 or
the DC7 is actually at this point the first and only one which is mains powered, where you have like the mains input included, right? And then the Cioks 4, which we call the C4, and Cioks 8. These are add-ons. They lack the AC/DC section, and they should be used either as extension units for the DC7, or we also have the C4 coming out with the adapter in adapter kit version.
Okay.
You could also use the C8 as standalone with the adapter, but in my opinion, it doesn't really make sense because you are very close to having the same number of outlets as in the DC7. So if you're considering buying the C8 and then getting an adapter for that, because we won't be supplying that, then you might as well get a DC7 because then you get it in one package. Which will be more compact and more reliable solution actually, because you have it like in one box, right?
Well, I'm a huge fan of the two of those. I use them together, and the DC7 and the DC4. So I'm very happy user of it. But I want to kind of get back to the beginning of how you even got into the business of making power supplies, how Cioks Power Supplies got its start, how you got your start. Can you kind of take us through that?
Yeah, I can make a short version of that because I usually talk a lot. But I was attending high school, and I used to play guitar back then, and had a few pedals. And by that time, you had these Boss adapters or batteries, and most of the pedals were analog. But you could actually buy a multi-output power supply for pedals. We are talking about late 80s. And I think it was a Danish guy who made this box, and it was like 500 kroner, which corresponds to, I don't know, $80 or something. And I found it not very nice in terms of design. It didn't look like something that was very reliable, and for me it was very expensive. And I by that time I already was interested in electronics. I knew I would study electronics, so I thought I could make something which was better. In terms of pricing, I didn't know anything about running a business, so I didn't know about how much a shop would earn on that, and taxes and all that stuff. So this is kind of a good thing, being young and naive and have a lot of time, because you just start off, And I did some drawings, and it finally ended up with being the baby power supply with 5 outlets. They were not isolated, but it was very compact, very small unit. It was putting out 280 milliamps, which was fine. At that time, you had, Boss pedals were out, and these were those I knew. And maybe a few dot pedals. And they drew like 5 to, 40 milliamps. So having 280, that was more than enough. And this is when I actually wanted to form to establish or how do you call it, formally make the company, but you had to be 18. So the company was founded on my 18th birthday actually. So it's been almost 26 years now. 27 almost. 27. It's 27 this year. Yeah.
So it was 1992?
Wait, 28. I'm not good at counting birthdays, you know. So it's been a while, and from that we continued. We made the Big John, which was kind of a bigger version of the baby with 7 outlets, and a bigger transformer with 7 outlets and 600 milliamps. And then came the double jack, because a few of those Boss pedals had 2 different original adapters, the PSA, which was regulated, and the ACA, which was non-regulated. And from the non-regulated, the pedals received around 12 volts. So I made these 12-volt outlets mainly for those who had these Boss pedals, which were intended to be used with the ACA adapter.
That would be like the Boss DM2 or the VB2.
Yeah, some of the first ones. I've got a list. I would have to open it up, but there were quite a few of those pedals. The first chorus pedal. And if you power them of a pure 9-volt power supply, the LED will be quite dim, and it wouldn't work as it was intended to. And the thing is, actually, because all those pedals could run off a 9-volt battery. And it was actually an internal resistor that made this voltage drop from this 12 to 9 internally in the circuit. So it was pretty straightforward. There was also a diode preventing wrong polarity on the input socket. So, and from that we in 2004. I was studying electronics. It took a while because I was running the business. I was working. I was partying. You know, life was great. So it took me 8 years to become an engineer, and then I worked for Bang & Olufsen and Siemens for a few years, and then I went full time with Cioks. And in 2004, I founded a sister company in Poland, where I'm based now, and the idea was to outsource production to somewhere else outside Denmark, and Poland was an obvious option for me, as I come from Poland. I speak the language. So I founded that here in the city where I actually lived the first 12 years of my life, and then I moved back to Poland in 2009. So after spending 25 years roughly in Denmark, and then we came out with DC-10 around 2010, and this was like big breakthrough for us, because it was the first fully isolated power supply which accepted American voltage, 120 volts, and had that switch, and it was made in a metal enclosure, and this was actually where we became global and start selling to US, Canada, Australia, Singapore, well, all over the world actually. And from there we did an update on the old products. We had a basic line or a standard line of it was called Schizophrenic, Big John, and AC Ride. They are still available where you could link them actually. And 3 years ago, we jumped into the switch mode technology, and started developing the DC-7, which came out in late 2018, and we are very happy for that, because it's actually that's a huge step if you compare our products. I mean, one big step with the DC-10 going from plastic enclosures and we did actually, before the DC-10, made the Schizophrenic, Big John, and AC Rider in a plastic version where the schizophrenic had 6 isolated outlets, and it was actually a very nice product, but the current for each channel was quite limited. So that's a few years ago. That's actually 2007, something like that. Yeah, and these were only for 230 volt, the European voltage. So I'm jumping a little bit because I didn't kind of prepare this. But this is where we are. This is kind of the short version of the story. Yeah.
Okay. I think that is. I think it's an interesting story. You know, the one thing that I always remark, I think that in the minds of consumers, the belief is that most people that are making their products are actual engineers like you are, and it's a very limited number. You know, it's maybe fewer than 10%, I would say, in our industry are actually engineers for the guitar pedal. You know.
Yeah, but I must say also that with the DC7, I mean, the switch mode technology has been around for many years. I studied that, but I haven't used that in my products. So I graduated and became electronic engineer, the master studies in 2001 or late 2000. But didn't really use the switch mode technology in my products. So we have employed an engineer who is a specialist in that, and he is the main man behind the technology in the DC7, also with my other engineer Tomek here in Poland. So I'm kind of defining the products now. I'm taking care of the mechanical design, the overall definition of the product, how it should look like, but the electronics, we have made the DC7 so compact, so you had to actually not just use the switch mode technology, you had to cross some borders. You know, I don't know how to say it in English. It has not been an easy task to fit everything and in a box that small.
Right.
It's I mean, shaving going from 5 centimeters to 4 maybe that's not a big problem, right? But the thinner you get, each millimeter or each tenth of an inch gives you some headache, which components you can use, which you can't, and how to be. I mean, the electromagnetic components, coils and transformers, you get quite a few limitations when you go down in size. So, and I think this 1 inch profile is, of course, you can go thinner than that. I mean, you can always be better, thinner, more powerful, all that. But the question is, will people pay for it? And is there a reason for that? I mean, one of the big companies making pedal boards, it's Pedal Train, and they have a whole line of flat boards. And this was kind of, well, you have to fit below these, because a lot of people, they put the power supply underneath. And that is made of 1 inch profile. The profile in the Pedal Train boards are 1 inch, and then you get a foot on that, which is 10 millimeters, which would be like, I don't know, in inches, a little bit less than half an inch. And you have to get some clearance to the floor, right? And 1 inch is a nice round figure, and we thought that this is where we aim, and this is now our new standard for all the new products, right? Yeah, I don't know where we started the question actually, but
well, we were
the engineering
with
part. So you have to play the right cards, and you have to know the technology really well, how to make a product really compact, really powerful, and giving you all these options of voltages as well. So
yeah, it's an excellent supply, and I highly recommend people check those out. I want to move to the second question, Paul, which is, Can you explain the importance of regulation and why it's important to maintain a constant output with line voltages in current draw loading?
Yeah, I can explain that. I mean, regulated, non-regulated. And your next question, actually, you have you've prepared here can be combined with this one, because if you look at a linear power supplies and the regulation, you have a voltage regulator there, and it's basically two tasks it has to take care of. One thing is to get rid of all the ripple, the grid frequency, right? It has to regulate that out. And linear regulators are very good at that. So they have a rejection ratio for this grid frequency. So in a non-regulated power supply, is just in a linear type, is just a transformer with a bridge rectifier and a capacitor. And what you get is a DC voltage which would have some ripple on it. And that ripple, if you're talking about very simple pedals like fuzz pedals, wah pedals, which are built up on a few transistors, their power supply rejection ratio which is a figure which tells us how well is any type of noise on the power socket, how well is damped, and how much of that will go into your audio signal. And if you're talking about these very simple pedals, this figure is very, very low. So if you have some ripple, some 120 hertz or 100 hertz ripple on the supply line for a wah pedal or a fuzz pedal or overdrive, some of it will go into your audio signal. And this is what you don't want. This is why you use a regulator to get rid of that. So you get a clean DC voltage. In terms of regulating the voltage, so it's not depending on the load, because this non-regulated power supply, the more you load it, the more the voltage will drop. If you take a digital pedal like an Eventide, the old factor pedals, like the time factor. Originally, it was made with a 9-volt power supply adapter, power adapter, which was non-regulated. So you could supply with anything in between, 9 and maybe 13 volts, because it had an internal switching power supply. So it didn't really matter what you fed it with. So if it was 9 or 10 regulated or 11, you would have the same performance from the time factor. If you're talking about some analog pedals, the Deluxe Memory Man. I don't know. I don't really know if it's digital or analog, but I know that it's sensitive to the supply voltage it gets. It's a 24-volt pedal, vintage pedal. The original power supply for it was non-regulated. I think I mentioned that to you last time we spoke together. But the thing is, the oscillation pattern in that pedal depends on the voltage level. So here is not about the noise on the DC voltage you supply the pedal with, but the level of the voltage. So the pedal actually acts differently. It operates differently at different voltages. At 24 volt it would not oscillate. One customer said at 27 volt it will oscillate. So it's a different way it sounds. It acts differently, right? And then you have pedals like fuzz pedals, which would sound differently. This is because you'll be getting more headroom with a higher voltage, and you will probably be operating at different places on the characteristics on a diode or a transistor when you have a different supply voltage. So they would sound differently. And is this why regulation is important? Well, yes and no, because if you have a non-regulated power supply, you don't really know where you have a voltage, right? It depends on the load. If you have a regulated power supply, you can adjust the voltage, set it to something. You can set it to 9, you can set it to 12, maybe 15. And this can influence the sound. And if it's not like this Deluxe Memory Man thing, I mean, having 9.2 or 9.3 or 9.6 volts, for most pedals, I would say, it shouldn't matter. You shouldn't be able to hear that. But we spoke about that last time. People have different ears, right? They hear different things. So you will also see that a 9-volt power supply for pedals can have anything in between 9 and 9.6 volts out, right? And a fuzz pedal, which is intended to be used with a battery, might actually sound differently using 9 or 9.3 volts. And it might also sound differently using different types of batteries. But these are very specific pedals, and I would say these sound differences going from 9.2 to 9.4 volts will not be significant, I would say. Going from 7 volts to 9 volts, yes, I would say that people will be able to hear that. But I must say, this is not a field I have investigated a lot. I mean, we don't do as you did, make battery things. You know, we don't emulate batteries. We haven't done that. We have no plans for that at the moment. Sorry, I have to interrupt that because my daughter is just calling me from the balcony. She's out in the garden.
Okay.
Just a second.
That's okay.
Okay, we have some cartoons going on now, so I hope we can have another half an hour now. So
okay.
Yeah,
No
but basically,
problem.
I mean, if you have a power supply and you have this regulation in means of either a linear regulator or you have a switch mode DC-DC converter, which is regulated, you have a very well-defined output voltage, no matter what the load is, and also you have a very good ripple rejection ratio. So this voltage will be totally clean, right? I also closed the window because we have some other kids making noises. It's not going to be a studio in any way. So it's home environment in this Corona time.
That's okay.
But this is so. I mean, for I wouldn't say how many percent, but for most pedals, for most users, you would like to have a stable voltage with no noise on it, and you can count on that, right? And then you have these special things that would need either a different voltage where you would like to have it a little bit lower or higher. And this is because this particular pedal would sound differently at these different voltages, right? I mean, you have a Moog pedal, or many Moog pedals. If you look in the manual, you would see either 10 to 15 volts is okay, right? Or you will see 9 to 12 volt is okay. You get an OCD from Fulltone, you see 9 to 18 volts is okay, right? And the pedal would sound differently at different voltages. When you have these 4 different options on each tab here, you can actually try that out with a pedal like OCD, because you have the options. You have to always consult the manual if the pedal is actually can take the higher voltage, right? And then if you take a fuzz pedal, or it's basically mainly the fuzz pedals, they are really where you have a lot of discussions, use this or that battery and that would sound differently and different voltage. I mean, we haven't done much in emulating batteries. This is not something I've looked a lot into because I think the market for that is limited, so I didn't concentrate on that. And I can't really contribute with much here, but I can tell you that it's not just a question of voltage, it's also a question about the internal resistance of the battery. It's a whole transfer function of in what way is the battery being a power source. And you can make a lot of tests and try to emulate this. I mean, and maybe some people have luck with this or not. But this is not our business, kind of thing, right?
Right. Yeah, I've only seen people address one of the variables, which is the voltage. They don't address the current aspect of it because there's a current limiting thing on carbon
Yes.
batteries. And also the voltage fluctuates, as you know, with a carbon battery. Not only is it degrading constantly, but also you can, if you put measurement tools and you slam the input of the device really
Yeah,
hard,
it's
you'll even
dynamic
see
because
temporary drops.
it has a transient function. It's not just resistance. It's probably also a coil equivalent and a capacitor equivalent. So you can actually build this function up and try to emulate in electronic circuits. So, but as I said, I didn't spend much energy or time on doing that. So this is like not our business. Yeah.
Yeah.
But I mean, regulation is important because of the two things. One, you want to have a well-defined voltage which is not dependent on non-dependent of the current you draw from the outlet. So if you have like one of our outlets on the DC7, we guarantee that up to 660 milliamps of current draw at 9 volts, this voltage will stay stable, right? It will not drop. And the other part of this regulation is that you are not, you don't get any noise because that is filtered out, regulated out. There are two things you can do with noise. You can regulate it out, you can kind of suppress the noise or the ripple, and you can filter it out, right, by passive filter components. And usually you use a combination of both in a power supply to get the lowest noise figure as possible.
Now, what about the difference between a linear and switch mode power supply? Can you talk about that? Because I think there's a lot of confusion. So just kind of like if you could kind of distill the basics for a hobbyist that's in the market for a new power supply, why might they want to choose a linear versus a switch mode, or the other way around, a switch mode versus linear?
I would say if you just look at the box, and if the power is made properly, if it's a linear or switch mode power supply, and they are both good, high quality, from the user perspective, you don't care what it's inside, right? But it has a meaning. It has an impact on the, for instance, the compactness, the weight, right? So if we say that linear power supplies and switch mode power supply are as good as, I mean, it doesn't really matter noise-wise, they're there, and reliability-wise. You will be able to have much more power from a smaller box with it's due to the efficiency. The switch mode power supply are much more efficient. I mean, if you want to make a linear power supply with high power, you lose a lot of power, and that would transfer into heat. And if you make the box too small, it will just get too hot. So this is why we can make this one and put out almost 50 watts of power at different voltages, and it's isolated, and it's very small and very light. If you wanted to do this in a linear power supply, it will be probably 3-4 times bigger and twice as heavy, right? So, but inherently, I mean, if you go back in time, people say no, we don't want Class D amplifiers, we don't want switch mode power supply because it's noisy. And I think also in the amplifier world, I mean audio amplifiers, also amplifiers for guitars and bass. If you go back 20 years ago, it was probably quite crappy what was on the market. I'm not sure, but the thing is that technology has improved, right? The components has improved. You also have a question. Well, what has happened? I mean, there has not been the invention of the transistor Now you could have a transistor radio. You could replace these valves or tubes with transistors. That was a huge step, right? Now in electronics, to build a very nice switch mode power supply, it's a slow but steady development in semiconductors, in different capacitors, in different materials for cores of the coils and transformers. It's all that put together. If you spend more money on the components and you use high quality components, you can get a higher efficiency, and you can make a more reliable and a better product, right? But I mean, if this is why a lot of companies, without making names, I mean, you can make a lot of text, marketing text, a lot of buzzwords. Nobody understands that, but it sounds good, right? But a linear power supply or a switch mode power supply, if it's made correctly, the power a pedal will receive will be good, right? And then it doesn't really matter what's inside, but it does matter if it's half a pound, or like 5 pounds for a box, right? Because you have to carry it. It does matter how many outlets you have. It does matter what kind of voltage options you have. I mean, we went with the same generic standard. So if you need 18 volts, you don't have to. You don't have to use a special outlet on a unit, because this is where you have 18 volt, or the possibility of having 18 volt. If it's convenient for you to use outlet 4 for your OCD because it's very near this outlet, you just use that and flip this outlet to 18 volts. So I think that these are the factors that should matter when you're choosing a product. And of course, also in terms of branding, there are a lot of no-name Chinese products. There are a lot of branded Chinese products which are made in China and sold directly on Amazon. And I'm not saying that everything is crap or good, or it's like with cars, you know. You can have a Lamborghini, you can have a Mercedes, you can have a Skoda, you can have a Fiat. It's everybody knows that. But I mean, 5 years worldwide warranty, for instance. This is something you can relate to, right? And it's worldwide. I bought a Canon camera, not cheap one, some years ago, and after I think 15 months, it was dead. And I figured out the warranty was lapsed, or how you call it. The 12-month standard warranty was gone, and I had to repair it for like 20% of the price of the camera. I had to send it in and wait a month or something to get it back. So I think that is something that is really important. The support part of it. Can you write to somebody where it's a real person behind the answers? This is also important, that you actually can get pre-sale support, and also after you've bought the product, you have some problems with it, or you have a pedal you don't know how to power. It's actually possible to write an email without knowing Chinese and get an answer, right? Mm. So this is what brands are all about. It's not just paying the higher price because things are made in a special region of the world, right? So, well, I don't even remember what the question is.
No, we were talking about switch mode versus linear.
Yeah,
I think you gave a great explanation.
I don't think you should buy something because it's switch mode, because it's linear. I mean, if you're buying an amplifier for your guitar, you might want a tube amplifier. This is because they sound differently. But if you buy a good switch mode power supply or switch mode based power supply for pedals, or a good linear one, your pedals will sound the same. They should sound the same, right? If you can hear some differences, maybe you can. You have some very good ears. You should be employed by some kind of acoustic. You should be an acoustic consultant, maybe then. I don't know. But you should rather look at what do I need from the power supply, or not I want a switch mode power supply, or I mean, if you want the most modern thing, you go for that, but you don't go for that just because you want to brag that you have the latest edition of a Cioks unit or a Vodolab or Strymon unit or whatever, right? You buy it because you have some objectives with what you want to power, how many outlets you want, what kind of pedals you want to power, right? So this is more what I would look at. You look at the weight, look at the number of outlets, what kind of voltages do I need, in what number. You know, if you have 4 different 18-volt pedals and you want them keep them isolated, well, you should look for a power supply that can give you these 4 18-volt outlets, right? If you have a very high current pedal where you need it, maybe high current at 12 volts, like some of the Kingsley tube pedals, well, you should look for a power supply that can supply you with that. And not concentrate whether it's linear or switch mode, but in most cases you'll get the main benefit of a switch mode product. It would be weight and size. These 2 factors actually.
Right. What about the external sort of environment, though? You know, like a problem that many people run into with the linear supplies. Again, as you said, not all of them are equal, depending on who the manufacturer is. But on a lot of the pedal train ones, for example, if you put certain devices over a linear power supply, the device can be sensitive to...
Yeah, I mean, this is also, I would also add this, and also the most of the switch mode based power supplies, they will have this universal mains, so you will be able to use it anywhere in the world, including Japan, where you have 100 volts, without flipping a switch. Because on linear power supplies, you usually have a primary winding on the transformer split in 2 sections, and you either connect them in series on top of each other, and then you have this 230 volt option for Europe, or you connect them in parallel, where you can use it in US, right, or Canada. And usually, if you forget to do this correctly, you'll blow a fuse, right? So this is kind of inconvenient for people traveling from Europe to US and touring, because you have to remember to set the switch correctly, right? And in switch mode power supplies, if you have a AC/DC converter in the beginning of this switch mode based power supply, it will adapt to the input voltage. This is why we call it universal. This is one very also important advantage behind the weight and the size, right? And then you're mentioning about the stray magnetic field, electromagnetic field from which usually comes from a big transformer in linear power supplies. If you have a power supply which has 8-10 outlets and it's kind of a powerful one, the transformer will be big, and the electromagnetic field around it will be significant. And if you have a wah pedals, you should keep it far away from that, because wah pedals are those mostly sensitive to those fields. And in switch mode power supplies, you don't have this big transformer running of the grid frequency. You have transformers which are running on frequencies far above your hearing ability. So the lowest frequencies in switch mode power supplies would start at 30 kilohertz or 40 kilohertz, and they would go up to 300 kilohertz.
We hope they're out of the audio frequency. I've seen some switch mode power supplies by name brands that they are in the audio frequency.
Okay, especially maybe if you're in audio business, you should keep it above that, definitely. But then you have an input filter on all switch mode power supplies, and that operates on the grid frequency, and you have coils and that. So it's not. I mean, some companies say it's noise free. It's zero noise. It doesn't make noise at all. I mean, there's no such thing. Everything is noisy in a certain extent, but how bad is it, or how good is it? So in the DC7 or in a Strymon Zoomer, or if you take a True Tone One Spot Pro, right? You have an input filter, and that operates on the grid frequency. And if you take a wah pedal and you position it exactly on top of this place where you have the coils in the input filter, you'll be able to hear that. But I mean, if you just take a wah pedal and do like this in the nearby switching power supply, you say there's no noise, because it's no noise compared if it was a linear power supply. It's definitely much better, right? And there is no this big transformer. It's just a few, one or two typically coils in the input filter that would have the grid frequency emitted from the box, right? But it's also a question about this the core type and the type of the coils used in this input filter. So there is nothing like the zero noise thing. I mean, zero. There is no zero. Well, if you turn the thing off completely, then you get a zero figure. It's everything is in dBs, you know. It's a logarithmic scale, so it might be that low, so you're not able to measure it, or you have to have very special equipment to measure the noise, or it's that low so you can kind of call it zero, right? Yeah, but this could be one of the bullet points of where the switch mode power supply has a huge advantage over the linear ones, and I'm pretty sure that in 5, definitely 10 years from now, you will not see any more linear power supplies on the market for pedals, because the advantage of using switch mode technology for that type of product is just it's obvious, right? So,
can you talk to us about why you choose? You're the only company I'm aware of that chooses RCA plugs.
We are just about to make a small video about this, because we get this question quite a lot. Well, it goes back in time where I started the business, and it's quite funny because those I don't have any here. But if you look at, for instance, a pedal power from Voodoo Lab or any other power supply that utilizes the DC. The standard Boss standard DC plugs, they are rectangular, right? And I didn't have the facilities to mill a rectangular hole or to order that big number of enclosures that I could get rectangular holes. So I had to choose a socket where I could drill a hole. I mean, I was able to drill round holes with this power drill I had in my apartment, right? So this was one thing, but I also figured out that especially on this Danish power supply I mentioned earlier, they used 2.5 millimeter jack plugs on the power supply end, so a non-standard plug type and socket. And that was really crappy. I mean, 3.5 millimeter, these are the ones used in the old wah pedals, in rats, or older dot pedals, right? The mini jack.
1/8 inch.
Whammy, yeah. Whammy? Also the original whammy?
I think, I don't know, that was
saying
AC.
something else.
I was saying that it's 1/8 inch is how people
in inches. Sorry, okay. I thought you were saying the whammy. No, but so I was looking around for can we use something that is that's definitely not a 2.5 millimeter jack plug, because that was crappy, and the DC plug didn't seem to be a very good connector. And then the RCA was like kind of also a very common thing in audio industry, and I could get them for a fair price. And I did some tests, and it seemed to me like it gave you a much better mechanical fixture, and also the surface where you're actually connecting both the minus and the plus, it's much larger, so it gives you also a much better electrical connection with a lower resistance. So this is basically the biggest reasons for me to choose that. So.
It's certainly a superior connection. That's undoubtedly, I think a lot of the reason why most companies are using the 2.1 millimeter barrel size is just because that was what was established before most of the, for the pedals, before most of the power supplies.
The jack plug, the 1/4 of an inch, right? Am I correct? Or what's the standard guitar jack plug? What's that in inches?
Yeah, 1/4 inch.
Yeah, 1/4 inch. Yeah, it's not a very good connector. I mean, XLR, that's a good connector, right? It clicks in place and it gives you a balanced signal. But a lot of stuff is from the old days, and we stick to that because it's a standard, it's easy. But I mean, with time, some standards evolve, right? Because people figure out, let's change this to something better. It'll not be easy. It'll take time, but when we get there, we have a new standard for something, and it'll be a better standard, right? So it's like I'm thinking the parallel port for the printer. Then we have the USB. Now everything is USB-C, and so I don't know. Maybe in 20 years, the standard for guitar pedals in terms of powering will be a completely different plug and socket. I don't know.
Yeah,
for now, let's stick to these two standards. I would say that in the beginning, where our brand was not that known, it was tough for people maybe to get our cables different places in the world. I would say that now the situation is much better because we have distributors and dealers all over the world, and also because there's one thing I'd like to add. Yeah, because we are giving with the power supply, you're actually getting quite a nice set. With some power supplies, you get only the DC-DC standard cables in one length, maybe, right? And then if you want a send a positive thing, you have to either buy an adapter or a different cable. If you want to make 18 volts and you don't have it on tap, you have to have a series adapter where you combine two outlets, right? And if you look at the sets of cables we include with the power supplies, we actually also include some of the most special ones. So you don't have to go and buy one of these if you need a cable for eventide, which is a center positive 2.5 millimeter in the center.
Right.
If you have a Moog pedal or I don't know, a fast pedal with opposite polarity, you have this red flex cable, the Type 2, so you get one of these. Of course, if you have multiple strange pedals that needs very strange non-standard plugs, you have to go and order these separately. So, but we also offer these. Oh, something happened.
Let's see.
There's some kind of battery exhausted. Oh no.
Oh,
we should have a power supply.
I actually do. Hold on a sec. I got a power supply. I forgot.
I check up on my kids, okay, Mason? Just a second.
All right. All right.
Yeah, I'm back.
Me too. I got the power
so we're
supply.
talking about the cables. I'm home now, so I don't have the new updated version of this guide for cables. But I mean, they're all color coded, and you get this guide with each power supply. And at the moment,
I'll put one on the screen for us I'll
send you the new file. But I mean, we have recently added the type number 8. Which is for Volcas, the cork drum boxes and keyboard things. I mean, there are guitar players that uses these, and also those desktop music makers having all these drum machines, sequencers, and stuff like that. They use pedals as well. So we've added that cable to the assortment to also be able to support the users of these. So I think at the moment the standard flex or the cables we have, we are around 40 different types and different length and stuff. So maybe we have a special connector on the power supply side, but you wouldn't be able to say that we have there's nothing to choose from, you know. So the availability in a certain region, if you're, I don't know, if you're in Missouri and you're looking for a local dealer and you're looking for a special flex cable, yes, okay, you might have a problem then. But I mean, if you're in US, we have our distributor in US has this Cioks accessories.com, I think it's called. So he's offering our accessories online, and it's quite cheap to get it sent out to and Sweetwater is also offering our cables rebranded as Eventide cables. They have almost the whole assortment, so it's easier now, right? But instead, if you have a bunch of the cables in the drawer and now you need one with the RCA on it, okay, you this is how it is, you know. It's
right. Can you walk me through whether there's any advantage of using coaxial cables versus the pair style that's on the Cioks? We talked about this a little bit before.
We talked about this. Yeah, I thought about this once again. I mean, if you take one of our cables, which is like side by side, and you split it in two. So you make actually a loop with an area, and then you find a very noisy environment where you have maybe some power cables, I don't know, a radio station in the neighborhood. You'll be able to pick up some stuff, right? If they go in parallel, side by side, the area of this one winding coil is very small. I mean, if you're making a prototype of some switchboard electronics, you sometimes use twisted pair. You also use twisted pair for internet, right? And then you have coaxial cables, shielded cables, and then you have balanced cables. So I mean, you can also take it to a higher level, and even a balanced cable which is shielded. If you have an atomic bomb exploding like 20 feet from you, I mean, that would probably be, you'll probably be able to measure that inside this shielded balanced cable, right? So it's a question of, I mean, if people are making their own cables with gold-plated RCA plugs, if they fancy that and thinks that this looks really cool and nice, that's fine. Honestly, I don't think they would gain any noise improvement or sound quality improvement doing so. If they do their own cables, then you are relying on your own soldering and not on some third-party soldering of the cables. So you know you made them yourself, and this is good. This is good stuff, right? You can cut them into length, so you can get them exactly the length you want them to be. But I would say, for sure, if you have 10 pedals, 2 of them would be made in such a crappy way, so the internal electronics in them, I have to be careful what I'm saying now. No, let me put it another way. There would be different factors in a pedalboard design and wiring and routing and overall the quality level of everything, where if you have to look at the cables and make them into, I don't know, balanced cables on power side, it doesn't really make sense to me. I would say to get them to the right length, if you like some kind of cables because it's nice, it looks nice, some cool plugs or something, that's fine, you know. Mm-hmm. You have also on your list of the questions here, if you should use specialized boutique AC power cables, which cost several $100s, you know, you can buy them for hi-fi equipment. Well, I don't believe in that stuff. I really don't, because then you reach the AC socket in your wall, right? And the wires in your wall, if you're living in a building like this, which was built 100 years ago, they're probably aluminum. I don't know. No, they have been actually I don't know, renovated.
Updated.
So, but no, I don't dig this stuff. I don't think that. I mean, if you have a set of loudspeakers that costs like $500,000, well, maybe you should have a cable that costs you $300 to connect your amplifier to the wall socket. There's a match there. But I would never spend that kind of money on loudspeakers, because I don't think I'll be able to hear the difference. You know, there's some you get when you increase the price from, say, if we talk loudspeakers, hi-fi. I've got a nice system here, right? B&W speakers, and if you say $1,000 for a set, for a pair of speakers, and then you go to the double, I would say most people will be able to hear the quality is different in what they hear, right? And then you go to 4,000, maybe you go to 8,000. When you go from 4 to 8,000, well, you have to really have good ears to be able to hear that. I mean, there will be subtle differences. Some people will be able to hear it instantly because they're used to hearing that stuff. You know, they are trained in hearing this. And I think that in a pedalboard, patch cables of higher quality would be a much better place to invest your money, or getting a good power supply, definitely also there, right? And then if you are talking about a more complex system with some loops and maybe a switching device for switching your loops, this is where the fun begins, you know. Then you have to be really careful about the ground loops with your amp. If you have several guitars, this is where you should look for sources for noise and stuff like that. All this talking about true bypass and buffered pedals and also switches. This is something that actually that you can talk about, and you can argument for this and that. But you know, if my guitar will sound better or will have less noise by using gold-plated RCAs or not gold-plated RCAs, this is a nonsense talk, right? Yeah. So I wouldn't actually spend much time on that, even if I know that a lot of people are talking about this. But this is just not my business. This is not my thing, right? I picked the components for my stereo system by some reasonable measures, right? If I cannot hear the difference between A and B in a blind test, there's no reason for spending this extra money.
Right. And, you know, back to the AC cord, though, you know, like the one that goes from the wall, in terms of the physics of it, though, like, is there really any scientific way to show that AC cord, by buying one that's a certain composition, would realistically have any impact? Because it's like you said, I'm in agreement with you.
Talking religion, you know, it's if you have a guy which believes in God and the other one doesn't, and they talk together about religious stuff, that would be a interesting discussion for some, and for some people it would be not very useful, right? And for me, a power cord should be reliable. It should be made properly. It should be enough copper to give you. I mean, so the resistance of the cable is not that big, so you don't get any voltage drops on it, and it should be certified, so you don't get electrical shock by touching it, right? But apart from the resistance in an AC power cord, in my eyes, not really. I mean, I remember I read a long article about USB cables to be used to connect a CD player with the amplifier, which has built-in digital to analog converter, and they were sort of talking about different sounding of different USB cables. And that was fun. I mean, that was funny reading, because I didn't believe any of this. and you had like USB cables which cost, I don't know, $400 for a USB cable, right? Speaker cables, yes, because you have a lot of signal. You have a powerful signal. Signal cables, to a certain extent, yes. And I know I'm probably making a lot of people angry, but I think that the level of again, if you have speakers that cost you, I don't know, $4,000, right? I wouldn't buy the cheapest signal cables because the soldering is done probably by some Chinese workers when one of the 100 solder points are maybe not as good as they should be, and it's signaled, right? Yeah, I mean, I don't have to explain that. It's not. And you can do it much better than I can, I think. My opinion on that is that you should. I mean, in terms of plugs and cables, yes, where the signal flows. All right, you have the capacitance, you have the inductance of the cables, resistance, the plugs. That can be measured. And you're forming a filter, and you have a lot of pedals in the chain. It will influence your sound, and everybody knows that. Everybody knows that if you have built a pedalboard with 5 pedals, if you've used crappy patch cables, you will actually hear the difference right away. So we don't have to discuss that. And again, you're probably much better expert on that than I am, because I haven't built that many pedal boards that you have, and so.
Yeah, well, the other question I have, and this is sort of about pedal board related stuff, is there's also a lot of people that don't understand that, like if you're wiring your pedal board or whatever you would be doing at home yourself, a lot of people believe that they need to separate their DC cables, going to their, say, Cioks DC7 from their shielded coaxial patch cables that are connecting the signal path. And I just always told people that it's too low voltage and low current. This is not going to be something that's going to be a problem if you have even like a basic patch cable that's shielded. Like there's just not going to be any issue.
Again, I didn't do any measurements on that, but just from my knowledge in physics and electronics, and I know a little bit about these two things, because it's a DC voltage flowing in these DC cables, right? And the currents are maybe maximum 1 amp. And the voltage is like 9, 12 volts in that ballpark, right? And it's DC. So, okay, if the pedal draws the current in a certain pattern because it's a digital pedal, so even if it's DC, you would have some fluctuations and you will be able to measure that. But again, you have these 2 parallel wires and they will cancel each other out. So I think I really doubted that you split the DC cable. You take really some kind of digital pedal which has a horrible in terms of the current draw, so you can actually, it would have to be a very badly made pedal because it would have to have no filtering. I mean, we have filters on the output here, right, of the power supply, and I wouldn't say all because I haven't opened them all, but most. Yeah. All the pedals I've seen, they have capacitors on the input. They have a filter on the input socket on the DC. So you would not have much. There's no zero. I mean, then you have to turn off the power. There is something. But whether this can travel from the DC power cables into your signal because they run aside, I would say no, I don't think so. But I haven't measured that, and it's just from my, this is my best opinion. So yeah, I have measured it. I'd rather not tell you something, which I haven't. I have some figures which I've measured, and stuff I know for sure. This is how it is, and then I tell you that. When I talk about this subject, I'm telling you what my gut. What you said, gut feeling, or what I think. So again, this would be something that I wouldn't look into.
Yeah.
I would say that it doesn't really matter.
I have measured it. I have measured it, and I can't. It's literally indistinguishable. And even in the highest gain environments, where you would really reveal this stuff, it's just not, audible. And it's an easy thing for somebody even to test themselves. Really, I mean, to a degree, you could start moving the cable loom around and see.
Definitely. Before you sort of stick them with the. Into the pedalboard and arrange them nicely. You can have stuff on your floor, and I actually suggest that people try that out, because it's much easier to move stuff around when it's just sitting on the floor, and see if it does have an impact. The order of pedals, the way you arrange them. I mean, people put. Funny stuff in the pedals, This company, what's called New Concept Audio. It's this with this high voltage thing inside.
Game changer
audio, right? I mean, I don't know what's inside it, but if it looks very noisy, so I could imagine. I don't know. I haven't tried that, right? But having that pedal. In close proximity to another very sensitive pedal. I don't know, maybe they shielded it. They have shielded it really, really well, and you can't measure anything. I don't know. I haven't tested that. But the thing is, everybody knows a wah pedal has a coil. So if it's an electromagnetic field in the neighborhood and it's in audible frequency range, you have troubles, right?
Yeah.
So arranging stuff on your floor and trying things out, if it goes well in the proximities, that is a good idea, I think, before you put stuff on the pedal board and fix it in place.
Yeah. I used to take, in the old days, when there was only really linear power supplies, I had connected a single coil pickup, with the cord on it, and I would put it over the power supplies to try to identify the electromagnetic field, so I would know when I put it down how we could try to avoid it as much as possible.
The geometry of the transformer is actually playing a big role here. So you can have a box with the transformer inside, and if it's toroidal transformer, they would have an even distribution of that, because it's a donut, right? But it also depends on how the windings are placed on this donut, right? But if you have a EI core or a UI type of core, you will have the field lines going out like a butterfly,
Right.
And so it's not the same in every direction. So if you have to have a very compact pedal board where you want to fit the power supply, and you have a few pedals which are susceptible to that kind of electromagnetic field, you should be careful where you place stuff, right?
Yeah. Yeah, the pickup would help me identify that, so you could kind of hear.
We've made my very first thing was actually I made a coil myself. I took a top of a Coca-Cola bottle and winded up some wire on that and put it into the oscilloscope, and I had this like a probe. But I mean, a single coil pickup is exactly the same, right? So
yeah. That's an easy way to do it. Now, the next thing I wanted to ask you about was, there's the linear, there's a switch mode power supply, and most of the companies are making them in enclosures like you are. But there's some that are sort of these that are plastic, and they've kind of dispersed.
I know what you're referring to, and maybe we should actually say that. I'm thinking about maybe putting that on our website, because you have different groups of power supply. You have like this is a pure switch mode power supply with AC mains input on it, right? Mm-hmm. Then you have a pure linear power supply where you're going in with mains and you're going out with 9-12 volts, and it's purely linear. Then you have those which uses a combination of switch mode linear technology, where you get some advantages of the switch mode stuff and then take some advantage of the linear. And then you have those where you have two separate boxes. So you have some DC-DC converters inside a box, but you have to feed it with a lower DC voltage. That would be our Cioks 4, Cioks 8, like the Ohio from Strymon, like X4 from Voodoo Lab. So you don't have the AC mains part in that. So you have to have a source, either a power adapter or another power supply feeding this satellite unit with either 12 volt or 24 volt DC, right? And then you have a system by a British company you're probably referring to, where you have an adapter which is capable of giving you maybe 12 volts and say 5 amps, which corresponds to 50 watts, right? And then you have these smaller boxes where you have either just a parallel splitter, so you don't have any isolation, but you just split it. And then you have these small knobs where you can make the cables into your length. And then you have boxes where you can have some isolated channels. And you have those making 12 volts, 18 volts, 15 volts, right? Is that what we are talking about? I mean, we're talking about the gig rig system, basically, right?
Yeah.
I mean, it's not a secret. I mean, we might as well say it's a way of it's an approach, right? Which they chose to go ahead with. Some people love it. I would say it's if you have a bigger pedal board which uses different voltages, it will be rather expensive. So this is one thing. The other thing, if you look at the reliability of such a system, you have a lot of small boxes you have to fix in place, a lot of connections. I would always go for simplicity, and simplicity will also be reliability. So having like one brick or one enclosure where you go in with mains, and then you go out with isolated outlets for your pedals. This is the simplest solution you can get, right? Then you have two boxes where you have the adapter and the power supply. This is a little bit more advanced, one step. But if you have like 6-7 different boxes which form your power supply, you have, of course, more connections. And connections, if you can avoid connections, I think it's better to avoid these.
Is there any disadvantage in terms of loop area that's created by the dispersion of all those supplies like that?
Oh, say it again. I don't think I fully understand your question here.
Well, so some of them aren't isolated, as you said.
Yes.
You have the option to add the isolators, but is there then a concern if you're splitting off like that of increasing the potential for a ground loop, since you have the single source that is being split in parallel?
I'm not sure that I understand you correctly. I mean, you have these. You have one box which is called a distributor. It's basically you go in with two wires, and plus and minus, and then you make it into 4 pluses and 4 minuses. This is just a parallel connection of where you have these clamps or where you can connect your cables. So that would be a similar thing as a daisy chain, but if you draw it, it's a little bit different, because the daisy chain, the plugs are on the cable, right? And here you have like a star system, right?
Right.
You do the parallel connection in this box, and then you go to different pedals. It's like we have a split cable where you have a plug to the power, which goes to the power supply, and then you give one cable going to one pedal, and the other cable goes to another pedal, and the connection is made here, right? And you can say, if you make the connection here, you're closer to this filter we have on the output, right? If you make a daisy chain, you have a cable, and then you have a plug, then you have a cable and a plug, and a cable and a plug. So if you think about that, on the end of the daisy chain, you have a pedal that draws. I mean, crosstalking between pedals because of daisy chaining them. This is one problem with daisy chaining. The other is ground loops, right? So if you have a digital pedal that draws the current from the power supply in a certain pattern, which is the pace of your delay, for instance, and you daisy chain that with the fuzz pedal, you might be able to hear this. You turn off the delay, but in your fuzz pedal, you can hear this pace of your delay. I would say, if you go for daisy chain, that effect, which you don't want, would be more probable than splitting directly from here, because then the pace of your delay, which is on the power line, will have to go very close to the socket where we have some capacitors, and then go to the other pedal. So most probably, or you'll have a chance, or you'll be lucky that this capacitor would actually take care of that. So using a split cable for two pedals that should be isolated would be better than using a daisy chain.
Yeah,
but in terms of this distributor from the gig rig, I haven't opened one up. I did open. I know exactly what's in the isolated box. I don't know if they have any capacitors there, because if they in the distributor you have a bunch of capacitors, I would say that would be a slightly better solution than just the daisy chain. Maybe I'm just giving them an idea now to put some capacitor in the box, but I doubt that. I would say it's probably completely passive box, which just makes a parallel connection.
So would you say that system is more susceptible to a ground loop than a system where everything's in the brick?
Well, a non-isolated system is definitely more susceptible to a ground loop problem, yes. But if a non-isolated distributor versus a daisy chain is more susceptible to ground loop, I couldn't say that, because ground loop is a question about the area in this loop.
Yeah.
You have to have you have like a loop, and then you have the electromagnetic field lines going into this loop, generating a current. So you have to have an area, and you have to have a certain resistance, because that electromagnetic field which goes inside the loop generates a current. If it's a very low resistance, you would not get a voltage out of that, and that would not then be into a noise signal in your guitar signal, right?
Right.
But because they are going side by side in pairs, this ground loop thing would be I would say,
minimal.
I would say it's not that. It's probably the same, but I haven't done any tests with that.
What would you say is the disadvantage? What would you say is the disadvantage of that system then versus the brick, or is it? Do you think it's more of a matter of taste?
I would rather not in an interview like that or any other place, talking badly about competition. It's a different way of doing this. It gives you. There is no limit on the expandability of it. If you need more outlets, you just add a distributor, or you add this isolator box, right? And then now I'm trying to tell you some positive stuff about this. But I personally, I like things to look nice and neat, and you can of course arrange it in a nice way. By placing these boxes nicely and put them in place with some dual lock and stuff, and arrange the cables. But it's much easier to just have one box, and then have the outlets.
Sure.
But it's also a system that has been around for many years. So I think that there's some evolution in all businesses, and in the power supply business, I would say that. And again, I don't like to bash competitors for different reasons. We did state that this is the best power supply in the world in NAMM, right? And of course, I would like to talk about our products, that they are very good. But things are evolving. I mean, having the possibility of choosing 4 different voltage options on each tab, and not every time you get a pedal that needs a different voltage, you have to go out and spend maybe $30 on a small box that will give you this voltage. I can't see that should be an advantage in any way. But you can do this. I mean, you can expand it. I mean, if you need 8 isolated outlets from that, you need to buy 4 more, right? Well, in their case, you also have to buy 4 more because they come in quantities of 4 isolated. So it's a very flexible system. It's a very expensive system. I don't like the flimsiness of having all these plastic boxes. I mean, if you weigh 200 pounds and you step on it, it will definitely break, right? So the durability of that system is not super high. But on the other hand, if you have this placed very nice below your pedal board, nobody will step on it.
Unless you place your pedal board on something, unless you place your pedal board on top of something where it could possibly damage the bottom.
Yeah, but I mean, you know this. If you want to ask me, it's not a system. If I didn't make power supplies, it's not the way I want to go. I would go.
Yeah. Well, what about in terms of solderless DC power cables? I noticed that there's a lot of companies releasing these.
I've seen the video you've done, and there's a lot about this in the internet. And my view on that is that have a look in what way the connection is made inside this jack plug. It's a barrel. And it's a spring, right? And the spring is a sheet of metal. So theoretically, if the barrel is round and this is flat, you have 1 point of contact. 1 point. And if on that particular point you have like a spot on your jack plug or something, a bad coating, that already is a bad connection. So the jack plug inherently is a rather bad connection. And then you have one end soldered to the PCB, if it's a pedal, or to some small wires which are soldered to the PCB. And on the other side, on the plug side, you have either a solder cable or the solderless screw in or like George L where you stick it in and I would say that no matter if it's solderless or soldered, the worst part of that connection would be inside the jack itself. This is just I actually spoke with a friend about it, and he made me aware about this, and so I'll leave it to you or others, because I don't have any experience with that, and you have the solderers, there are different systems, and there are differences probably, how reliable they are, what's the impedance of the connection, how nice it looks, what kind of cable are they using. So the cable itself used specifically for that system is also important to ask whether this is a good cable or not, and how does this cable sound like, right? I mean, what are the properties, the physical properties of a evidence audio cable or a George L cable, or might be different.
But what about for DC though, in particular, solderless DC power cables?
I would say if the connection is okay, and this is of course what is an okay connection, I would say fine, go with that. But it has to be, it has to be reliable in a way, right? I would say I don't have any super opinion on that because I haven't tested that.
Right.
So I would rather base my answer on some tests. It's like suddenly some people said that malaria medicine was good for corona patients, right? And everybody was, oh, great, we have a cure, right? And 3 weeks later they said, oh, the side effects are bad. They are worse than the other stuff, you know. So for me, talking about it, of course we can talk. It's nice to chat, but I can't really. I don't have any measurements or experience with this. So I would rather not give a definite answer. This is what I think is better, because I can't really. I can't really tell you for sure, right? Because I haven't measured that. If I had 20 friends that had done this and we have been talking about this, I would maybe have a knowledge which I could share with you. But I really don't. I really don't.
Yeah. Well, if you're interested, I can share what I found, but it may not be of interest to you. I have two more questions left, Paul. The next one is, what is the kind of arc or timeline of developing a new product look like for you when you're developing a new Cioks product?
It depends on where you are in the business. I mean, if you have to make something from scratch. When we started with the DC7, I had some ideas, some objectives, what I wanted to make. And I knew I had to reach out for the switch mode technology, and we would have to work hard to get it so compact and so versatile as I wanted it to be. But once you have like the building blocks ready and you have the basic technology ready, then it's easier, right? And also some form factor which you can reuse. But this is very general speaking, right? In the old days, it was harder because you had to know what people actually had on the pedalboards, and you had to be very precise what to offer, because you had limited power. I mean, you had, if you want to make a power supply that size, you knew that you could fit that kind of transformer inside that, and from that you had a limited amount of power you could draw, and that limit was actually, you should distribute this power into maybe 8 outlets, and you couldn't make them all 400 milliamps and 9 and 18 volt and 12, because that was not possible with the linear technology. So it was about to make some statistics and looking at what do people have on their boards. And suddenly Eventide is releasing the factor pedal, time factor, mod factor, and all these. Then you have TC Electronics releasing the Nova series, right? Then you have Strymon releasing some pedals. I was out measuring all these pedals because I couldn't give you that much headroom, because then you will only get 5 outlets instead of 8. So in terms of designing what type of outlet and what the possibilities would be for each outlet on the power supply 10 years ago, it was much tougher to decide what to offer. And this is why we had so many different power supplies. And now where you have like 660 milliamps at 9 volt on one tab, you can power almost, I don't know, I wouldn't say if it's 99 or it's 97% or it's 95, but most pedals would be fine with that power, and you have loads of headroom, right? And these very few pedals, you can't power with one tab, you get the parallel flex, and then you have 2 tabs, and you have more than a 1 amp, and that means that now, and you have 4 different options on each outlet. So for now is more how many outlets and what form factor. I mean, the reason for having outlets on the sides is because this is made to fit into those pedal train boards which are flat. It fits directly into that, and then you lock, you don't have access to this side and this side, so you have to access the box from the shorter sides, right? And now you can ask yourself, I mean, what next? And I will not answer that question. But I mean, I'm not shutting down the company next month. So of course we are thinking about new products, and lot of the technology we need, we have that already, but of course we also develop some more.
Yeah.
I don't know if this is answering your question.
No, I'm I was just curious about it. I think that's a totally acceptable answer. And I have one last question for you, Paul.
Yeah.
Which is if for some reason, you took a different path and Cioks, never existed.
Yeah.
What would be a power supply that you would recommend to somebody based on what you know is out there now?
I mean, I would say it's tough it's difficult to give you a simple answer. I mean, if you have $50 for a power supply, well, you can't get the branded ones, right? You go on Amazon, right, and buy some Chinese ripoff of the existing stuff, or this is how it works. But say if you go to money is not a problem, it's not an issue, right?
Yeah.
And you're looking at Strymon, you're looking at Voodoo Lab, you're looking at the True Tone, and you're looking at MXR. I think these are the main players in this game. NMXR, they have only products at the moment, as far as I know, where you have the adapter separately, and then you have a box which is fed by 18 volts, and it says MXR. Right? Some people buy a Crybaby because they see big posters of Jimi Hendrix, and he played a Crybaby, so they want this wah pedal, right? I wouldn't go that way because I would rather have it in one box. Okay, it leaves me with the blue one, the True Tone, and Voodoo Lab, right? Strymon and Voodoo Lab and True Tone, and Strymon is at the moment the only company having a pure switch mode solution. So this is why they offer the same current on each tab, because they have an individual transformer for each outlet. And if you like that, the possibility of not having to choose which outlet to use, this is nice, right? True Tone, they're utilizing the switch mode technology to get some benefits for getting the weight down and getting a lot of power. But I mean, the CS12, it's a rather big power supply. It's rather tall, and then they are using linear regulators on the outlets, and this is why they cannot offer you any voltage on any tab. And those tabs which has selectable 9 or 18 volts, they have a lower current, because if they stated 500 milliamps on these and you used 9 volts, and that would be regulated in the linear regulator, you will lose a lot of power. So if you think that you will change a lot in your pedals, you will use a lot of different voltages, I wouldn't, and with higher currents, I wouldn't go the True Tone way. Now, Voodoo Lab, they have just released the Pedal Power 3 and 3 Plus. I mean, they haven't released it yet. They have, it's just been set for sale at pre-order on Sweetwater. They have shown these two products at NAMM this year and last year. And I haven't opened it up yet because it's not available yet. But I would assume that, and this is where I might be completely wrong, but I would assume that they will use some of the technology which is in the X4, and then build an AC-DC converter to combine the X4 technology with that. And it's flatter than the Zuma, but still not very flat. So it's depending on what I would have on my board, how big it would be. Mm-hmm. So even if I should look away from our own brand products, it would really depend what I would connect to these power supplies. And I will not talk about what's inside, how it looks like, and where it's made, and all this stuff, because I keep that for myself. And if if somebody wants a personal explanation to this, that I'm open to a talk at NAMM or stuff like that. But I would not talk about this. But of course, I know a lot about these products because we have them all in our lab, simply because we want to know what's going on in the market, right?
Yeah.
But I know Bob Vale, Josh. I know also the what's his name, the Strymon guy. I can't remember his name. I have seen his face. I mean, I talk with them all, and I think that if you write to these companies, you get a reply. So the support part of it is also important, right? Mm-hmm. So I would, if I needed a power supply and I had like 10 pedals maybe or 5, or had some question, I would maybe shoot the same question to all these companies and see how they reply and how fast they reply. It would give me an idea of if I can rely on the support side of that. And then of course I will go and read a lot of stories on the gear page if somebody has some nice things to say about these products, right? But these are kind of American branded, American based companies, right? Where they manufacture their stuff, this is different, and you can set up the manufacturing in different ways, right? And it doesn't necessarily mean that if you go offshore that the quality would be worse or something. So you just have to make sure the quality is okay, right? So
yeah. Well, Paul,
it's not easy to answer which I would choose. Yeah. It will. I would say definitely it would depend on what I would specifically need of specifications for the product, what it should do for me. If I needed multiple 18 volts, well, there's maybe this is MXR has, I don't know, they have 4 taps or something. So it would depend on what I would actually need specifically for the pedals I would have.
Right. Well, I think that's a fair explanation. I think at least gives people an overview of some of the different supplies out there, and that there's some different approaches within that.
Yeah, I mean, also the mechanical part of it. I mean, what's the form factor of the power supply? What pedalboard do I have? Would it be easier for me to mount the power supply using the pedalboard I'm intending to use? Do I have to buy additional hardware to do this? How much does it cost? What kind of cables do they supply? I mean, if you have some odd pedals and you would have to go and buy some extra cables which are not in the set, you have to also include that cost and calculate what would the whole system set you back, right? So there are different factors. It might be easy to say, well, it's just a power supply, but if you really dig into this, it can get complicated. Not that I would like it to be complicated. I would like to make it as simple as possible for people. But you have to think about how many pedals do I need to power? Do I need AC? Do I have some odd voltages? Do I have some power pedals that require very high current? Right? Where would I like to mount the power supply? And how easy should that be? Should I have access to that? To these switches to set the voltage? A lot of questions actually, and you know that because you've helped people with building boards. You've built boards for yourself as well. So yeah.
Well, I really appreciate all of your knowledge and time on this, Paul. I think it's been very insightful to me to learn about you and your company, and then also your approach. And I sincerely appreciate you answering all these questions. I think that people are going to learn a lot from this.
I hope so, and thank you very much, Mason, for taking your time and doing this. And you're always welcome to email me, and of course, everybody who is listening to this or will be listening to this, you're welcome to write to support@cioks.com and get specific answers on specific questions which you might have.
Yeah, and where do you recommend people find more? It's going to primarily be an American listening audience, but we do have some European. where would you recommend people learn more about your products, and where might be the places that they would want to look to get them?
Since I'm an engineer and not a marketing guy, our website is not super updated. We are just about to do that because we've released quite a few products recently, and these will be put on our website now. I mean, I've Henning Poul from HB42 in Germany. I've visited him a couple of times, and we did some talking. And if you're just sitting at home and you like to hear that, there's also some information there. But it's rather I talk a lot. You figure that, so you have to have time to listen to all that. But I think also what we talked about would be more accurate and most up-to-date information, because things have been changing. I mean, if you look just 2 years back in the power supply business, there are a lot of changes been going on in terms of product being released. So if you talk to me maybe a year from now, I would probably also say things slightly differently, because the assortment of different products on the market would definitely change, right? So
yeah, and so Cioks.com is the website?
Yes.
Okay. And then in the US you have your own distributors.
We have Alpha Distribution. It's a guy named Jack Thompson. He's running the business, and people are also welcome to write directly to him in terms of where to find a local dealer. But we also have a section on our website with a listing of dealers, local dealers, any country in the world, right? So,
right.
But we at the moment we are thinking about building up a frequently asked questions section. But before that happens, I mean, the support email is open, and we have 3 different persons contributing to answering on that. Our Facebook has not been running really well. There are a lot of questions there which haven't been answered, but we are actually working on having that fixed. So. The support at Cioks.com is probably the most safe way of contacting Cioks for technical support.
So that was Poul Cioks of Cioks Power Supplies. We had that was a great conversation. I think that he talked to me about, a little before we started rolling, about some of the kind of key distinctions that he kind of wanted to align with as far as verbiage on power supplies. And actually he went through some of my other videos and gave me some corrections on things that maybe I was saying in terms of the lingo or the wording that I was using. In particular, he had told me that I was referring to linear supplies as analog supplies. And although that's something that I would see commonly amongst manufacturers of linear supplies, he really made the distinction that analog, in regard to linear supplies, really should only be reserved for audio signals when you're talking about analog, and when they're talking about power supplies, that it should be referred to as linear versus switch mode power supplies, instead of linear and analog being collapsed into one. And there were some other things, but he was very thorough about going through all of my other videos and really making sure that the questions that we hit today and that we organized together were the best representation of the best that we know around differences in analog, well, I shouldn't say analog, linear power supplies versus switch mode, and regulation and all that stuff that we talked about today. So I'm very grateful for Poul, and I'm really grateful that he took so much time to really look at the information that we had presented and then helping fill in the gaps from there. So I'd also like to thank our sponsors today, Blue Microphones, for providing us the microphones and headphones necessary in order to do this podcast. I'd also like to thank all of the people behind the scenes, Hunter Harrison for mixing and editing, Mason Mejia for his co-production, and Tim Marco for making all of the music with which you hear during and throughout the podcast. Until next time, I am Mason Marangella, the Rig Doctor. Adios.